Bananas are among the most cultivated crops on earth. Each year, over 100 billion bananas are harvested across tropical regions. Yet, for every bunch of fruit we eat, an entire plant is cut down, leaving behind what many consider waste, the banana pseudostem. Unlike trees, banana plants fruit only once. After harvest, the stems are often discarded or left to rot. Globally, this creates hundreds of millions of tons of agricultural byproducts, material rich in cellulose, water, and natural fibers, but largely ignored for decades. At a microscopic level, the banana stem is far from waste. Its layered structure is packed with long cellulose fibers, the same fundamental building blocks found in wood, cotton, and paper. These fibers provide strength, flexibility, and natural resistance to tearing. Industries searching for alternatives to petroleum based plastics and water intensive crops are now turning to overlooked natural resources. Banana stem fiber requires no extra land, no additional water, and no new crops, only smarter processing of what already exists. This realization gave rise to a new kind of facility, one that doesn't grow raw materials but rescues them. Here, the journey of banana stem fiber begins not in a mine or a well, but in transforming organic waste into industrial grade material. Inside these factories, agriculture meets engineering. Every system is designed to solve a single problem: how to extract strong fibers from a water rich plant without damaging their natural structure. The challenge is precision. Pull too hard and fibers snap. Move too slowly and bacteria can compromise quality. Timing, pressure, and moisture control are critical in turning waste into high performance material. In the next chapter, we follow the banana stem as it enters the processing system, where biology is stripped to structure and waste begins its transformation into engineered fiber. Freshly harvested banana stems arrive at the factory, marking the first step in transforming agricultural waste into industrial fiber. Each stem carries unique variations in moisture, thickness, and quality. Before entering the processing line, every batch is weighed and logged. Precise intake control ensures consistent processing, reducing waste and optimizing machine efficiency. Hydraulic systems carefully unload the stems onto conveyor belts. Smooth handling prevents damage, maintaining fiber integrity from the very start. Optical scanners and moisture sensors assess each stem in real time. Too dry and fibers risk brittleness, too wet and microbial growth could compromise quality. Despite automation, skilled technicians remove damaged or irregular stems, a critical step to ensure that only viable material continues down the line. Rotating rollers sort stems by thickness and density, aligning them for uniform processing. This mechanical precision prevents fiber breakage and ensures consistent output. A controlled mist of water adjusts moisture levels, softening fibers and preparing them for extraction. Proper hydration preserves flexibility and prevents tearing though once sorted and conditioned. The banana stems are fed into the extraction line where biology meets engineering and the transformation from waste to fiber begins. After sorting, the banana stems enter the extraction line, a carefully designed system where biology meets engineering. Here, the goal is to separate strong cellulose fibers from the soft plant tissue without causing damage. Heavy duty steel rollers gently compress the stems, aligning the fibers for extraction. This step reduces irregularity, ensuring that fibers remain intact and uniformly oriented. From the perspective of the fiber itself, we see the immense precision required. Pressure must be carefully calibrated. Too little and fibers won't separate. Too much and they snap. Rotating decortication blades then scrape away soft tissue, revealing the long, resilient cellulose fibers beneath. The process is fast but controlled, preserving structural integrity. As fibers move forward, pulpy plant residue is expelled through side shoots. This separation keeps the material streams distinct, allowing only clean fibers to continue. Tension rollers stretch and align the fibers into continuous strands. Uniform tension prevents weak points, a critical factor in producing industrial grade fiber. Here we see the result, long intact banana fibers glistening with residual moisture. Their natural strength and flexibility are preserved, ready for the next stage. Finally, the fibers move toward the washing section, where residual plant matter and impurities will be removed, preparing them for refinement and industrial use. After extraction, the fibers enter the washing hall, where science ensures cleanliness and stability. The goal is to remove all residual plant matter without damaging the delicate cellulose structure. Large water baths immerse the fibers, softening any remaining pulp. Gentle agitation helps loosen impurities while preserving the natural alignment of the strands. Enzymes are then introduced into the water. These biological catalysts break down organic residues, selectively targeting unwanted plant material while leaving the fibers intact. At a microscopic level, the enzymatic solution dissolves soft tissue, revealing clean cellulose bundles. This chemical precision is crucial for producing uniform, high quality fiber. Massive rotating drums tumble the fibers gently, ensuring even exposure to water and enzymes. Agitation must be carefully balanced to prevent fiber entanglement or damage. Sensors constantly monitor pH and temperature, adjusting parameters automatically. Even minor deviations can compromise fiber quality, so real time control is essential. Once cleaned, the fibers pass through cascading rinse systems, removing all chemical residues. Sparkling clean, they are now ready for drying and further processing. The result is